I'll let everybody in, and
Oh, that's perfect.
I almost have all the assignment ones ready to turn back. I'll have them ready to turn back in the morning, but I'm just going to kind of
Good.
hit some highlights on those.
Okay.
And then we'll talk about multiple regression or whatever y'all want to talk about. I feel like we're starting all over for some reason.
Well, it feels like that. No, definitely, because I've been trying to teach myself multiple regression, which that's fun. Because that homework, I know that Brady and I've been working on that, and then of course I know we got another one, so coming up after that. So yeah, multiple
Yeah.
regression.
And I did do a recording for multiple regression. And when I went on there tonight, it wasn't on I don't know why it didn't, because I know I uploaded it, but maybe it didn't complete or something, but I've added it. So there
Okay.
is a recording of the multiple regression also on there.
Okay. Perfect. Thanks.
And we'll do it, we'll go over it tonight also.
Perfect. Thank you.
Here comes everybody. Whew. Everybody survived all the ice without too much damage. The snow, the ice, the lack of water, lack of electricity, lack of cell phone service. That's what got me. Hey, Carla. That was pretty scary to me, is when we had no electricity, no water, and zero cell service. I mean, it's like we couldn't have done a 911 call if we needed to. Whew. All right, so y'all ready? I'm sure others will be coming on, but I want to get started on time to respect your time, as well as I have a 7:45 class after this one, so I wanted to give us plenty of time. What I was telling Mignon earlier is I'm almost through with the assignment number 1, and I should be able to get those all returned in the morning for you guys. And they look good. They look good. I mean, there's not anything in there that I'm going, the one thing that for everybody just to be aware of, the second question had to do with some different variables and what level they would be at. And the instructions said, to explain why you chose that level. The majority of people would say time is ratio or time is interval, and because it doesn't have a 0 point or does or whatever. But I think the most important thing to think about is whether it's time, whether it is age, any of those. It depends on how you measure it as to what level of variable it is. Now, eye color, ethnicity, political party affiliation, those are going to be nominal level. I mean, there's just not much else you can do with those. Those are names, they're categorical, they're going to be nominal. But say you're going to gather data on age, on your participant's age. You can ask them, what is your age today in years? Tell me how many years old you are today. That's really going to be at a ratio level. You can ask them, are you over the age of 65? Yes or no? That's going to be what? That's a nominal level. You could even do it categorically, and you could say indicate your age range. 15 to 20, 21 to 25, 26 to 30. So then you've got an interval level. So what is it? I think what's important for you to recognize from that particular exercise, and it's not that anybody got it wrong or anything like that, it's just that you have to be very explicit in how you're going to measure it to identify what level it is. Otherwise, you could get into some problems when you do your analysis. The other one, most of y'all did fine on the differences between qualitative and quantitative. Generalizability seems to be a little blurry at times, what's generalizable, and really in qualitative research, it's not going to be generalizable. Qualitative research is about the lived experience of those individuals, or the lived experience of the individuals who've written the diaries, or whatever that is that you're capturing, and you're looking for themes, and you're looking for trends, and you're looking for things like that, that you can then move into more of a quantitative approach, but you cannot generalize that information to a larger population. It's really going to be just for that sample population. Generalizing for the larger population really does come into the quantitative approach, and it has to do with your methodology. It has to do sometimes with your sample. If you're wanting to generalize from your sample to a larger population, you have to make sure your sample has characteristics of that larger population, which is usually done through random sampling. So it really does come into the methodology and meeting certain methodological guidelines before you can generalize beyond your sample. Those are the couple of things. Independent and dependent variables, I mean, pretty much everybody got that. And one easy way to think about that, especially since as practitioners, anytime you are evaluating an intervention, it will 100% of the time be your independent variable. Anytime you're doing an intervention, because you're always trying to change something with that intervention. So your intervention is always an independent variable. And then your dependent variable is whatever you're trying to change or address. And there can be extraneous variables. Those are the variables that you can't control for, that could potentially be impacting your outcomes in your data, and you really just can't, you're not controlling for them. If you control for other variables, they're not extraneous if you control for them. And there's statistical ways to control for variables and keep them constant so that they don't impact that data. But if you're not controlling for them, that's what those extraneous variables are. So everybody was pretty much on track with everything. It's just that those are kind of the comments I've gone in there and made. And like I said, it's not like you got it wrong or anything like that. It's just something to think about, a little bit more detail, a little bit more in depth on it. But other than that, they were looking good. So I should have those finished and returned in the morning, barring any major disasters. So now, y'all want to talk about multiple regression? Do you guys remember simple regression that we went over a couple weeks ago? Kind of, sort of. And you got the prediction, you got the prediction formula, and you were able to plug in those numbers so you could do some prediction. Multiple regression is really the same thing. It's just that you're trying to predict more of the variance. So if we were going to study, let's say we were going to study suicide in teenagers, and we want to know what variables are going to contribute to an increased risk of suicidal thoughts in a teenager. So we craft our study based on what we know from the literature, and we determine what our variables are. So it could be drug use. It could be victim of bullying. It could be victimization from sexual trauma. It could be the levels of depression. So there's several things that can contribute to suicidal ideations in teenagers. Well, obviously, as practitioners, we want to know as much as we can because we actually want to be able to alleviate those. So the more we know that contributes, then the more we can actually attack to try to alleviate it. Multiple regression is tools. There's really 3 different types, but they're the tools that we can use to determine how much of the variance in suicidal ideations can be explained by these different factors, these different variables. So if we had a study and we had 29 variables that we know contribute to suicidal ideations in teenagers, and we put those 29 variables into our multiple regression, we're probably going to be able to explain 100% of the variance of whether somebody has suicidal ideations or not. So we have to balance that because we really don't want to have that many variables. We want to be parsimonious. And parsimonious means we want to find the most relevant variables that can explain the most variance. So the fewest variables that can explain the most variance. That's what we're looking for when we use multiple regression. I'm going to share my screen and put up the PowerPoint. And this is the PowerPoint that I also recorded to, so you can go back and listen to it. There. Can y'all see it? Okay. So multiple regression is just a set of some statistical tools that we use to assess the relationship between the dependent variable and more than one independent variable, several independent variables, because we're wanting to explain as much variance as we possibly can with as few variables as possible, because that means we get more bang for our buck. Okay. So when you're talking about multiple regression, let me move this down a little bit. All right. There's some things that you have to think about first. And so regression techniques are used when independent variables are correlated. So the correlation among the independent variables, because we don't want multicollinearity. So I'm trying to explain this. Okay. So the independent variables have to be correlated, okay? But we don't want them to be highly correlated with each other. Otherwise, we're going to get some white noise in there. So we want them to be correlated, and then we want them to be correlated with the dependent variable to a certain extent. Because remember, if variables aren't correlated, then one's not going to change when the other one changes. So if we're going to manipulate our treatment intervention, it's going to have to be correlated somehow with our dependent variable. Otherwise, it's not going to impact it. Okay. So regression techniques have to have some correlation in there. They're an extension of that bivariate regression that we talked about with just the one independent and dependent variable, and it gave us that formula. So this just looks at it with more independent variables. All right. So it's the same concepts, but just with more independent variables in there. This is the regression equation that we get when we're talking about multiple regression. And it's basically the same thing, but this right here is your independent variables. Y is the predicted value on the dependent variable. That's what we're going to be able to predict. Okay. A is the y-intercept, and that's the value of y when all the x's values are 0. X's represent the various independent variables right here, x1, x2, x3, and the xk just means to infinity. Okay, so it just goes to infinity. And then the b's are the coefficients that are assigned to each of the independent variables during the regression. And these are the things that we look at when we get our output, okay? It's not, again, it's not much different from the simple linear regression. Oops, let me admit her. It's not much different from the simple linear regression that we've looked at before. It just takes into account more of the independent variables. There's different types of multiple regression, and what we're going to see the example of tonight is just plain multiple regression. There's also the sequential multiple regression, which is hierarchical, or there's stepwise regression. Those are a little bit more complex, and you choose those based on theory or for a theoretical difference. And what it does is it determines how the variables get entered into the equation. When we do simple multiple regression, it just puts them all in there at the same time and then determines the variance. If you're going to do hierarchical regression, then it's going to do one variable at a time, and stepwise we'll put one in and take one out. So they're just a little bit more complicated in terms of the multiple regression, but it's still looking at the impact that the independent variables are having on that dependent variable. And this just breaks it down. This particular slide breaks them down. The standard multiple regression, which is most commonly what we use. You really do have to have a strong theoretical reason to go into sequential or hierarchical regression or statistical stepwise regression. Most of what we do from a practice standpoint in the type of research that we do, we're going to use standard multiple regression, okay? The other two, you have to have a reasoning as to why you're selecting certain predictors and in which order you're selecting them and all of that. But this particular slide breaks down the different definitions of the different types of regression. So doing multiple regression in SPSS, you basically do the same thing that you do when you run linear regression. You just put more of the you just put more variables in there. So multiple linear regression assumes that all variables are at an interval or ratio level. And remember, in behavioral sciences, we tend to treat interval ratio variables the same. The big difference is ratio has an absolute 0. And for technical reasons, with the ratio, it's the highest level, and we can actually do addition, multiplication, correlation, subtraction. With interval, you can do addition and subtraction, but you can't do proportions. We tend to lump that all together in social sciences, and we tend to treat interval ratio as the same when we're running our statistics, okay? The dependent variables should be normally distributed around the prediction line, and that assumes all variables are related to each other linearly. So this is an assumption of multiple regression, that the dependent variable has some normal distribution. So that's something that you have to check. That's a factor that you have to look at. In addition, all the other variables should also be normally distributed. If they're not, then you have to make decisions about, do you go ahead with the multiple regression? Do you do some cleaning of your data? Do you do some manipulation that's appropriate to do to make sure that your data meets this assumption? In multiple regression, you can also use the dichotomous variables such as gender as independent variables, and these can become, if there's more than one category, if it's male and female, it's not too difficult. You just use 2 categories. If there's more than one category, you'll get into the dummy variables, but you can use those as independent variables in multiple regression. You need at least 3 variables to do multiple regression, and each subject must provide data on all variables. So what this means is if you have 50 participants in your study, and you're going to do multiple regression, and you're going to look at 4 independent variables on your dependent variable, all 50 have to have contributed data on all of those variables. So if you have some that you did not get data on some of those variables, those have to be removed. If if all 50 people did not provide data on all of that, then you have to remove them. So you may go down and you may only have 40 people instead of the 50, but they have to do that for multiple regression. So basically, again, you're going to do essentially the same thing that you've done before, and you're going to move this over here. You're going to do the analyze, and you're going to do the regression. And over here, you're going to put in your dependent variable. And then over here, you're putting your independent variables. So right here, the only difference is you're just going to put in multiple independent variables. Otherwise, you use the same formatting as you did before. You're also going to be interested in the same output as you were before, which is your model summary, your Anova table, and your coefficients. Just like you were before, you're going to be interested in those things. And you're essentially going to read them in the same way as you did when it's just linear regression. So the example here that I used had to do with gender, height, and weight. So we determined that the dependent variable weight can be explained by variation in the independent variables, which is height and gender. So our dependent variable is weight, and we're saying we wanted to know how much a person's gender and how much their height explain differences in weight in our sample population. Okay, so in the model summary, we look at the R squared right here, and it says 99, it says 0.993. So you change that into 99%. So 99.3% of the variation in weight can be explained by differences in height and gender. That's what your R squared tells you. It tells you the percentage, essentially, of the variance that's explained by both of those together, okay, by height and gender together. So just with those two independent variables in there, we're explaining almost 100% of variance in weight among the sample population. And for ours, taller individuals weigh more and males weigh more. So here, when we ran the simple linear regression with the dependent variable being weight based on height, so I'm using this as an example. So if we just run simple linear regression and we're interested in how much variance of weight is explained by a person's height, just their height, not their gender, then we look at this model summary and this R squared says 0.649. So basically 65% of variance in weight among our sample is explained by the person's height. And remember, we had almost 99% whenever we had gender in there, okay? So that's going to leave what? 44% explained by gender. But that's what happens if we just use simple linear regression and then we use one independent variable on the dependent variable. It tells us how much is explained. When we run multiple linear regression and add the independent variable of gender to the mix, then we could count for 93% of the variance. Was it 93 or it was 99% of the variance, not 93. So when we add gender, then all of a sudden we're counting for almost all the variance in weight, just based on height and gender. So this is what multiple regression does for us. It allows us to explain the variance in our dependent variable among subjects based on these other independent variables. Is that kind of sort of making sense for y'all? Kind of sort of? And then we have the Anova table, and the Anova table gives us our significance. So right here we have the significance of the 0.000. So we do have a significant linear regression. It also gives us our degrees of freedom, 2 and 13. Okay, so we have the 2 and the 13. We report both of those for our degrees of freedom. And it gives us our F statistic, which is what we also report in our findings. So the Anova table is important for us because it gives us that information. It lets us know what the significance is, what our F statistic is, and what our degrees of freedom is. And in turn, we need that when we report our findings. So again, just a quick review there of the regression equation. I put that in there so y'all would have that to look at. So right here, we're going to We're going to look at our coefficients table down here at the bottom. And then our constant is weight. Okay, that's our dependent variable. So weight equals 47.138, right there, 47.138, minus 39.133, which is gender, right here, minus 39.133, which is gender, plus 2.101, which is then height. So we have our weight, our sex, and our height, or sex or gender. And this right here is where we coded gender with male being 1 and female being 2 and height in inches. So the average difference in weight for participants who differ by 1 inch in height is 2.101 pounds. Right here's our weight, 2.101 pounds. So for every 1 inch of height, there's going to be a difference of 2.101 pounds. Males tend to weigh 39.133 pounds more than females. We've got our gender here, and the reason we say that is because males have a value of gender that is 1 less than females. We coded males 1, we coded females 2. So males have a value of gender 1 less than females. So their predicted weight would be -1 times -39.133, which right here for gender. And basically that just gets rid of the negative, right? So we have males tend to weigh 39 pounds more than females. So each of these tables have some meaning for you. And this is how you read them. So here, a female who is 60 inches tall should weigh 47.138 minus 39.133 times 2, because female was coded as 2, okay, plus 2.1601 times 6. And that's going to be 94.932 pounds. This is our prediction equation.
Dr. Judd, I have a quick question if I can.
Uh-huh.
On this slide, is it 6 or should it be 60? Because you're looking at a
60. You're correct.
Okay, thank you.
Whoops. Yeah. So if you run that equation, you're right, because it should be 60 inches tall. So you would be able to take a female that's 50 inches tall and plug it in here, a female that is 48 inches tall, whatever, you can plug it into this prediction equation, and then you can determine what they should weigh based on their height and their gender. So if we look at the standard error of the estimate, which is right here, this tells us that 2.295 fall within that 66% of the bell curve. If we double that, 95% of females who are 60 inches tall will weigh between 90.341 and 99.523 pounds. Because we took the 2.295 and we doubled that, okay, and we got 4.591. So basically we're saying plus or minus 4.591, 95% of the females are who are 60 inches tall are going to fall within this weight range. Same concept as with simple linear regression. You're just looking at multiple variables in the equation. So 68% will fall within one standard deviation, one standard error, and 95% will fall within 2. That's where we get that from, and that's this standard error of the estimate right here. Clear as mud? And it may help for y'all to go back and print this off. And again, this is what I've recorded, and to actually physically work out those numbers so you can see how they fit into this. But this is the output you get from SPSS. So you get everything you need from SPSS when you put in your variables for multiple regression. When you put in your dependent variable and the independent variables all there at once, that you're interested in seeing how much variance you can explain in that dependent variable. That's the role of multiple regression. Other questions? None? So some practical issues that you do have to consider when you're going to run multiple regression. And again, multiple regression is to reveal relationships among variables. So it's looking at how much of the variance can we explain in our dependent variable based on our independent variables, okay, that we're putting in there. It does not mean causality. So we can't say height and gender cause a person's weight. And if you just think about it from a logical standpoint, while height and gender can explain 99% of the variance in weight, there's a whole factor of what we eat, how much we eat, when we eat, all of that kind of stuff. That would be more of a causation, okay? So it can look at the relationships, but this is not causality, all right? To be able to do causality that A causes B, that has to do with logical theory, and it has to do with your experimental setup. It has to do with your methodology more so than any statistical analysis. It's not a statistical problem. So we explain variance in there, but we don't explain causation. We use theory to inform the inclusions of the variables, just like we do with any of the other statistical tests that we're going to be using. We use theory to inform that. So we have to have a reason as to why we're putting those independent variables in there. We have to have that empirical evidence from the research that's been done before that says, yes, these are related. And then we also have to have some correlation. And so we would run some correlation, or you would get some correlation when you ran your linear regressions to make sure that those variables are correlated. So we have to know that there's a logical reason why we add our independent variables in there. We don't just throw them in there haphazardly, okay? And regression is best when each independent variable is strongly correlated with the dependent variables and uncorrelated or weakly correlated with the other independent variables. So if you think about this from a logical standpoint, okay, we want the independent variables to be strongly correlated with the dependent variables, because then we know when we manipulate that independent variable, that dependent variable is going to change. So we want a good correlation there. If we have 5 independent variables that we're wanting to determine how much of the variance or the change in our dependent variable we can explain, we don't want those independent variables to be highly correlated. Otherwise, we're going to get trash in there. So if 2 of those independent variables are highly correlated, then there's no distinction really between which one is contributing which amount of variance, okay? Because they're correlated, so you can't separate them out. So when you think about it, you want your independent variables to be correlated with your dependent variable, individually, but you don't want them to be correlated with each other. Now, there may be some correlation in there because of just the type of research that we do, and that when we're looking at things that are related to each other, but it needs to be a very weak correlation if there is a correlation there. Otherwise, again, you're going to get some false information there. You're going to make some false statements. And like I said, the general goal of regression is to identify the fewest independent variables necessary to explain as much of the variance in the dependent variable that we possibly can. Okay, so that parsimony, we want the fewest, most impactful independent variables to explain that variance in the dependent variable. If we have alphabet soup, you know, and we put in all 26 letters of the alphabet, then we're going to be able to explain everything. So we can always explain everything, but just by continuing to add independent variables, we can always explain that variance. But what we really want is the fewest, most impactful ones in there. So we have to really look at those assumptions. Ratio of cases to independent variables. And again, if you get large, that has to do with effect size. If you get large ratio of cases, you're going to be able to pretty much explain any variance if you have enough in there. Absence of outliers among independent variables and dependent variables, because this can skew some results. The absence of multicollinearity and singularity. Normality, linearity, homoscedasticity of residuals, independence of errors, and absence of outliers in the solution. These are all practical issues that you have to work through with your data to get good multiple regression information so that it's good results that you get. And good meaning that they're valid, okay? So if we look at ratio of cases to independent variables, then that has to do with our sample size. And that depends on your desired power, your alpha level, the number of predictors, and the expected effect size. There's some statistical ways to run that to determine what your sample size needs to be in order to get that good mix for your multiple regression. The rule of thumb, I personally don't think there's anything wrong with using the rule of thumb. There are others who really want you to use the correct statistical procedures to determine that and do a power analysis. But a rule of thumb would be a sample size of greater than or equal to 80 plus 8 times the number of independent variables. So if I'm testing 10 independent variables, that's a lot, but if I'm testing 10, then I would want N to be greater than or equal to 80 plus 8 times 10. So 80 plus 80, so 160. I would technically need 160 participants if I had 10 independent variables. For testing for the multiple correlation and an N of 104 plus M, if you're looking at individual predictors. So these are just some acceptable rules of thumb that you can use when you're trying to determine the required sample size to use if you're going to be running multiple regression. You know, so if you have 6 predictors, you need 50 plus 8 times 6, 98 cases to test regression, and 104 plus 6 equals 110 cases for testing individual predictors. And then if you're going to, you always want to go with the higher one. So you would use the 110 cases. So this is just an example of some things to consider when you're thinking about your ratio of cases to independent variables whenever you're needing a sample size. One of the hardest things that we find when we're doing our research is participants and getting the sample size that we need. It's tough to do. But again, you may have an advisor who wants you to do a full power analysis, which is a statistical analysis, and it's done in SPSS. Or they may say the rule of thumb is okay, so you can have an idea of what your sample size needs to be based on your independent variables to get what you need to use your multiple regression. You have to think about absence of outliers among the independent and dependent variables. And again, because outliers are going to skew that data, there's not going to be some normality in there. It's going to impact that. And it'll impact the regression analysis if you've got those outliers in there. So you have to clean up your data and you have to determine how to fit those outliers. Do you just discard them? Are you going to do some form of statistical analysis to make them where they're not pulling that curve one way or the other? In regression, cases are evaluated for univariate extremeness with respect to the dependent variable and the independent variable. So that's kind of what it's looking for. So you don't want the outliers in there. Absence of multicollinearity and singularity, okay? If you have either of these problems because of independent variables that are highly correlated, remember we don't want our independent variables to be highly correlated, or because you've included interactions among independent variables or powers of independent variables in your analysis. So these can be problems that you have to look at. Typically, this is going to happen if your independent variables are highly correlated. You're going to get the multicollinearity, and you're going to have to address that. Otherwise, you're not going to get good data. You're not going to get good results that are meaningful. And again, you can examine your residual scatter plots to provide for a test of assumptions of normality, linearity, homoscedasticity between your predicted dependent variable scores and errors of prediction. So this explains what your residuals would look like when you look at those, when you do those scatter plots to determine what those residuals to look like to see if you're going to have any problems there. The best thing I can tell you to do is that as you do this, if you identify the problems in your data and then you work through them, then it makes more sense in cleaning up that data. For me, I have to revisit it every single time when I have data. I can't just go, oh, I need to do the residuals, the scatter plots. I mean, I systematically look at it and go through it. And then it makes more sense if you have these problems in your data when you start cleaning it up. Independence of errors, and the assumption here is testable through, again, residual analysis, and that errors of prediction are independent of one another. So time, distance can actually impact this, and again, this is methodology, and so you can have non-independence of your in your residuals. If you took a long time to collect your data and you were collecting it with interviews, a scheduled interview, questionnaire, and say you took 8 months to collect your data, well, there's going to be a difference in quality. There's going to be a difference in skill level of the interviewers. There's going to be quite a bit of difference between the first and that last one. So that can give you some problems with this independence of errors. And then it can also be actually geographic. There can actually be physical distances. And the example here talks about the distance from toxic sources. So if you're actually looking at gathering information about how individuals feel living next to toxic sources, there's going to be a difference from somebody who lives right next door to it and somebody who lives in the next town. What you have to decide as the researcher is if you have these methodological challenges in there, then you have to decide, is the non-independence, is it just a nuisance factor, something that you're going to deal with to try to eliminate it, to try to clean up your data? Or is it something that actually contributes to your research, that actually is something of interest there? And then you want to make sure you have absence of outliers in your solution. And again, because some cases may fit poorly on that regression equation line that we have, cases with large residuals or outliers in the solution. So you have to look at those residual plots. If outlying cases are evident, then you identify them through the standardized residuals for individuals. And these are those scatter plots that you can get to visually see if you have those outliers. And again, you're going to have to make a decision what to do about the outliers if you do have those, because they're making your results potentially inaccurate if you don't address them in there. So those are just some of the practical issues when we go back to those model assumptions. When you start getting into multiple regression, these assumptions become important. Some statistical analysis are very robust against assumption violations, but multiple regression is not quite as robust against violating some of these assumptions. And so you have to make decisions as the researcher about which ones you're going to violate, which ones you're going to clean up, which ones are going to impact your results. And sometimes these can be, when you read published empirical research, you're going to see that there is weaknesses in it. So there can be some weaknesses in the data, but it's always addressed in there. If you clean up data, if you make changes in your data, whatever you do, you're going to always address it in that results section so that whoever's reading it knows what you've done to make your data fit the model that you're presenting. That is kind of multiple regression in a nutshell. So stop share. Does anybody have questions, comments? I know you probably want to go over it again.
Dr. Judd?
Yes.
So is there a way that you could actually go through an SPSS model and like show how this applies? Because seeing it on a PowerPoint for me does not transfer. When I go to SPSS and run a multiple regression, I have no idea what I'm looking at.
Okay. I can on the particular computer I'm on right now. I don't have SPSS on it. I have to get on a different computer, but I can set up a time to do that. So you would want me to actually live go through the SPSS?
Yes.
Okay. Would it be beneficial for me to do a live recording of it?
That would be good. When I was going over homework 2 and I got to the last question about like doing a multiple regression and then analyzing the results, I can run the regression, but I can't analyze the results.
Okay.
I don't know what I'm looking at.
Okay. So when you look at your tables, you don't know what you're looking at in terms of your coefficients,
right,
your Anova table, your
that into the models of assumptions. I don't know how to explain the linearity or any of that. I can't.
Okay. 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 I'm thinking of how best to do that for you.
And I found an article from Field because that data came from Field's data and that walked through like how to do the multiple regression, but it was like reading Latin when he was trying to explain it. Like I could follow the instructions on how to run the multiple regression, but then actually interpreting the data, I was completely lost.
Okay, so the actual...
You're not alone on that, actually. Like that is something that I'm kind of struggling with as well, as far as like trying to analyze all of that as well. So, you know, she's not alone on that.
Okay, well, that makes perfect sense. So the actual putting the information into SPSS and actually running it, pretty comfortable with that, but what you do with it once you have it.
Correct. I can't interpret it.
Okay. Okay.
And part of that too, this is Mignon, part of that too, like I know in the homework, there's a piece of the last question that's to write it up in APA style, and that's a piece of it. So I know what it looks like, that it's, what exactly are you looking for in that APA write-up? Is it like just what you have like here in the PowerPoint, like we're just writing these basic sentences of what it is that we found, or are you wanting the full spiel? You know, what exactly are you looking for in that APA?
Okay. First of all, if you go to APA, if y'all haven't looked, and I don't know because since I haven't had y'all before, APA has specific ways to report results. Okay, so you have to follow the APA way to report those results. So you know, and it's like when the examples I've put onto the PowerPoints typically follows that, because you have to include certain things when you're reporting your results. And like you have to include your F statistic, you have to include your degrees of freedom, you have to include your significance level, and there's certain ways to do that. So that would be the APA portion to it. When you're writing your results, it's really very dry. I mean, it's just the results. There's really no interpretation to it. There's no opinion to that. That comes later, but the results simply are the results. So you start out, when you're writing the results from a study, you're going to start out with your descriptive statistics. And you're going to talk about what your sample looks like in terms of on those variables, those descriptive statistics. Then your next step, depending on what you've run, you may actually have a section where you simply describe your multiple regression. It's just straightforward, exactly what came out. So I'm trying to think of the best way. What I can do is I can actually record. Except you guys do okay with running the SPSS. It's what you do with the output that you get. Correct?
I'm going to be real honest, Dr. Judd. I had to get that article by Field to walk me through step by step how to run.
Okay.
Otherwise, if you just told me to go to SPSS and run data, I'd have no idea what to do.
Okay. Okay. So maybe going all the way back to just the basics of the SPSS and doing it live, running through it live.
Yes. And I can tell you that's what Michael did with us in our first statistics class, was that he would start from the very beginning. He would run the data through SPSS. He would get the output, and then he would step by step walk through everything on how to interpret it.
Okay. Okay. So he would do that. So that would be how he conducted the class then.
Yeah, and that was the only way that I understood it.
Okay. Okay. Sure, we can do that. I'll be more than happy to do it that way. So y'all want to do it in a live class?
That would be great.
Like online in I hate that we can't be in the same classroom together.
Yeah. Ideally, I mean, when we took the first statistics, we started live in the classroom with him, and it was a lot easier.
Yeah.
People in our class took him when it was fully online, so they've never had statistics in person.
For the like when he did it online, and for the rest of our class, he would put each of those outputs in like a PowerPoint slide with each step. And so even if you weren't in the class or whatever, you could just follow each slide, and it would give you like the steps of how to run each one.
Okay, so let me ask you this. Let me try something here.
And some of it too, also, no one else said anything about this, but like our homeworks, these homeworks are obviously very detailed, but it was more so for us to get a chance to work on it. It wasn't to, I guess some of my anxieties, I don't know how you grade. So I have a lot of anxiety over, because we still haven't gotten our first homeworks back. So I don't know how you grade. And so his wasn't so much about the grading. It was about him seeing where we were with everything, and not trying to get us on a grade as much as it was like, I want to see where you are, so I know next week what to discuss and talk about and make sure y'all understand, because this is what everybody's making the same mistake, or everyone else said the same thing, that type of thing.
Okay. And then I approach it from the same way. For me, it's a learning situation. And so I want to see where you're at, and then where I need to go back and help you guys understand better. So I approach it from the same situation. Again, you're not going to see me. I'm not going to be saying, oh my gosh, you only got 2 points on this one, because it's not that. I want to see where you're at. And so like I talked about, I almost have the first ones done, and I'll get those finished up in the morning and back to you. And basically everybody appears to be having the understanding of those first concepts in that first assignment. The number 2 assignment, the first assignment, the second, those are his assignments 100%. I did not change those at all. I didn't change the wording on them. I didn't change any of those. If I were going to do them, I might do them a little bit differently, but that's just because we're different teachers. You know, we just approach it differently. So those are his homework assignments, but I will come at it from the same direction in terms of what do we need to work on here on that part. So to go back, I'm sharing my screen again here. So like where I have the output right here, when he did it online, how would he help y'all understand this output?
He literally did it in real time. Like he pulled up SPSS,
Yeah.
and like literally cut and pasted like as he did it, and it was literally in real time.
Okay. I think I understand that. So, okay. So were y'all, was it a live class, or did he record it that way?
Live.
The live class. Okay.
Did it both.
So
It was both. He had PowerPoints that had the voiceover, or else if you were in real class with him. I'm happy to pull and email you one of those PowerPoints so you could see what we're talking about, if it makes more sense that way, if you'd like.
That's true. We have access to all the old material.
If you wanted to see what we're conceptualizing in our heads.
Okay. I want to present it to y'all however best it's going to help, and in multiple ways if that helps. So I'm obviously not prepared tonight to go into SPS and do it live, because I do have to do that on a different computer. I don't have it on this one, but I can arrange for that. So what we can do next week, and we could have time essentially to do I've got the PowerPoint voiceover for multiple regression, but it's basically what we went over tonight. So it's not real time like that. But what I can do is, let me see if I can record a live one, just a live one of using the SPSS to help you out there. Next week, we can start and we can do an SPSS. I'll do an SPSX, physically do it, and exactly what you're explaining to me, and pull it out and show you what to do, as well as present you a write-up. And then we can still also fit in the t-test and the Anova. T-test and Anova are very simple and straightforward. They're not difficult at all. So we might be able to fit all of those in next week if y'all are willing to do that.
Okay.
Yeah, t-test and Anova. I think that would be kind of cool, Lisa. I think that's cool. If everybody else is. The other thing too that I was going to ask is, can you also get us homework number 3? Because there's some of us, we work, and I got like this next week, and I got to do homework. I got to start on homework 3.
you do, and I actually need to go back, because he didn't have a homework number 3. He had it assigned, but I don't have what his homework number 3 was. So I need to go back and let me develop a homework number 3 that's going to be beneficial, so I know what you are understanding. Okay. And I can push that due date back a little bit if we need to. Okay. So if it's going to be too quick, I can push that back some.
I was going to ask about that, since it's due next week and we're talking about not actually going through this live until next week. That doesn't give us time to.
Now, next week's homework number 2 is due, right?
Right, but that's where it has that question that right at the APA style of the.
Okay.
It's due on 3/7, so it'll be due
End of the week.
At the end of the week.
Okay.
That was going to be my next question. Is I know you updated the syllabus and wanted to see that, because we have the 3/7 for homework 2, and basically it's every other week we have a homework that's going to be due according to the syllabus. Is that correct?
I think that's the way it is. I did update it. I redid the schedule. Okay, so Next week on 3/7, which would be the end of next week, 3/7, the homework number 2 would be due. So that's that last Sunday night, okay? So the week begins on the 1st, and then on that Sunday night is when homework number 2 would be due. All right, so we still should have time next week. We can go over the multiple regression and the write-up, and then you would still have time before you had to turn it in on the 7th.
Okay.
And if it runs into a problem, we can adjust, that's fine, okay? Then I have homework number 3 due on the 21st, which would be 2 weeks. And again, that's on a Sunday night. Then number 4 would be due on April 4th. And then number 5 would be due on April 18th. And I moved the exploratory factorial analysis article till the end of the semester to give y'all more time for that.
So we have that and the presentation at the end.
And the presentation, and if y'all
And watch
haven't
the other
seen it
4.
yet, yeah. And again, because that was designed for face-to-face classes, obviously. And with there's 26, I think there's 26 in the 2 different sections here, and that would take a whole lot of time for everybody to present, and it would just eat up so much time. So I tried to come up with a way where I will obviously look at all of them and give feedback, but then in the groups, each one of you could give feedback on a limited number of them. Because I think it's important for you guys to give feedback too to each other as to how well it's communicated or understood, all of that. So that's how, read how I've got that written out there for the presentations. And if you have other suggestions, I'm open to that, okay? But I think it would be best for you to just record the live recording as if you were in a classroom doing a virtual presentation, since that seems to be where we're moving towards in the future anymore. But you would record like you were teaching it to the class in a virtual presentation and then upload that recording. So does the modified one look okay?
I'll be honest, I'm a little stressed out with the factorial analysis and the presentation too at the same time.
Well, you can do one of them early. I just wanted to give y'all ample time since the semester's been so messed up. I wanted to give y'all ample time. I mean, it doesn't mean you can't do either one of them early. I just won't be grading them until those times. And in here, Sarah made the statement, gender is not dichotomous. And you're right, it's not. I was just trying to just use that as the example for the male and the female in terms of just to get that across. You know, the 2 sides of a coin could potentially have been a better option on that. But to link it back to the height and the weight, I was just trying to use that as an example. So let's plan on this next week. Let's plan on me doing a live presentation from using SPSS. I'll share my screen with the SPSS. I'll run a multiple regression, and then I'll pull what you pull out of that multiple regression in order to write up your results based off of what APA and have the results so that it would follow what APA would expect.
I was going to ask if you have, besides just going and pulling random papers, do you have examples of like how to write up? I was looking at the APA manual, and in section 3, it goes over quantitative but there are no examples. There's examples of the qualitative reporting, but no examples of the quantitative.
Let me look at my APA manual.
Unless I'm missing it. Okay. There's pages and pages of examples on the qualitative.
Let me look here. $181. If you go to page 181 and 182 in the 7th edition of the APA manual, it does give a little bit. There's a hierarchical and other sequential regression statistics. It shows how to report those right there. F ratios, T values.
Okay, I was in the wrong chapter.
Yeah, spacing, alignment, and punctuation for statistics. It has those in there. Presentation of equations. So it does have some of that in there. Yeah, how to do confidence intervals. And then I'll see if I can find y'all some other examples also. Oftentimes you're going to find your best examples in your published research. So if you can find articles and you look at just the results section, just that results section, it should follow an APA format in terms of how they present that in that published literature, especially in the counseling, in social work, in psychology. They're going to follow that. And so one good way to learn how to write that is to mimic what others have done in that results section.
I kind of tried to take that approach from the field article I found that used the same data, and I tried to write it up, and then I had somebody else, somebody who knows statistics better than me, review it, and they were like, yeah, but you didn't kind of cover any of the model assumptions. I was like, see, okay.
And yeah, because you do have to address the assumptions in there. You know, were they a problem? Were they not a problem? So you do have to do that. So we can work on that. We can work on that because that's something that you'll have to be able to do, especially for your dissertation for that level.
I have a quick question since we're on the topic of APA write-up. I did mine, and I think I'm comfortable with like how to report that in APA. But the question I had was, are all like, so in the multiple regression output, you know, all of the tables, the coefficient table, the Anova, descriptives, collinearity diagnostics, all that, all of those values are equally important? Or is there something that's like, well, you run that, but you don't really need to talk about that? Or should I do them all and it be a page or two?
Well, it technically wouldn't be a page or two. The things that you really want to pull out in terms of reporting your results they're going to come from the Anova. But again, you don't pull everything off that Anova table. You pull off your significance level, your degrees of freedom, your F statistic. You pull off your R squared out of your model summary. So it's just those things that you pull out of those whenever you're reporting that. Results, unless you have just a majorly complicated study, your results section is not just hugely long. I mean, it's not pages and pages generally, because the results are it's the dry stuff. It's just the results. When you get to interpreting your results, that's where you get to what are considered your findings or your conclusions, those things. And that's where you put your opinions on it. But the results section typically is just straightforward, the results. This is what was found.
Okay.
On that part. So it takes a little practice to learn what to pull off of that SPSS output to put in there, when to use a table within your presentation, within your actual manuscript versus just explaining it in your text form in a paragraph. There's some different guidelines for that. If you use your descriptive statistics, oftentimes you'll see in a published manuscript, you'll see the table of the descriptive statistics in terms of the demographics of the population. A lot of times they put them in a table because it's easier to read than to put that into paragraph form. Okay. So if you have a matrix, if you have a correlation matrix, that's usually put into a table form. You never, ever, ever cut and paste from SPSS into your manuscript or your papers, though. You never do that. You always follow your APA formatting for your tables. So you go into the APA manual, you look at how you format for your tables in terms of your numbers, and then you transcribe your numbers into those tables. So you don't want to ever cut and paste from SPSS into your actual paper. But then you have to learn what it is you pull out and what you disregard. Some of the things there is for you as the researcher just to make sense of it, because it's just something that you go, oh, okay, this looks good. And it's not necessarily something you have to report. The main things you have to report, like I said, in multiple regression are those 4 tables that they're interested in: the model summary, your coefficients, your ANOVA. And then you want to address your assumptions. Did you violate the assumptions, or what did you do to address outliers? What did you do to address? And what I can tell you is there's differences in terms of where you're publishing, in terms of what they want in your results section. Some of them will say only put the assumptions in there that you had to address. Otherwise, if the assumption was met, there's no reason to make that statement. So sometimes they come from the exception. You only want to make the statement if the assumption, you had multicollinearity, so you did A, B, and C in order to correct that in your data. Anytime you correct anything in your data or you have violated an assumption, you want to share that. That all comes with practice. So this is good feedback for me, so I can create a lesson so that we can go into that more in depth.
Thank you.
Okay.
Yes, thank you.
That helps me understand what you guys are needing. So let me ask you this. Do you know how to choose what statistical test to run?
Yes.
I mean, would you know that for this particular situation, I need to run a dependent samples t-test versus an ANOVA, or this is appropriate for multiple regression? Are you comfortable with that? Or is that something that we need to look at also?
For me, I'm not comfortable with that.
Okay.
I need more help with that.
Okay.
Same here. If we can go over that, that'd be great.
Okay. All right. So because you have to have that background when you're designing your study and you're choosing your variables and you're choosing your measurements, then you're going to know, you should know what statistical analysis you're going to do after you get your data. Okay. So we'll go over that too. We can work on that the rest of the semester too, is how do you know when to choose which statistical test to examine which relationships?
I've got a question that goes back to the basics on multiple regression. When you're entering your data and you're looking at let's say three different independent variables, such as you're looking at depression, anxiety, ADHD for something. Each of those results is based upon some sort of inventory or assessment that you've used. Is there when you're entering that into SPSS, is there a point in time where you're putting a scale in there so that, you know, an ADHD assessment is going to have a numerical number, but it's not going to be equivalent?
Are y'all still there?
Yeah, I think she just froze.
You think it's her? I'm always panicking. Is it me?
I thought it was me.
Yeah, Carol, I think you froze. She went out a minute ago and came back on, so maybe she'll need to do that. Well, I hate to answer her question if she can't hear.
Hey, Dr. Judd.
Uh-huh.
I have recently, this is Erica. I recently got a manual, and you probably already know about this. It's called SPSS Survival Manual, and it has like a little tube, like a little saving, like not saving tube, but like a little life tube. I mean, I find it really helpful. It's like a worldwide bestseller, a step-by-step guide to data analysis using IBM SPSS. It's by Julie Kalan. I don't know if
Wonderful.
Just wanted to kind of give that out just to the class as well. But yeah, still going to need help.
Erica, would you type the name and the author in the chat so everybody can see it?
Yeah.
Prozac Publishing, they also do how to use SPSS, which is a pretty good workbook. I've used these before. This is an older one for older SPSS, but they're pretty good because what they also do is they give you how to write up results if it's significant, or how to write up results if it's not significant. So Prozac is a good resource also for you to be able to have.
I'm going to put I don't know if you guys can see it. I'm in my car, but I'm going to kind of turn on my camera and flip the screen around, maybe, if you can see it.
Okay.
Erica, you can pull the Amazon link and put it in the chat.
Or I would say, Erica, I was going to say, don't stress yourself out. You can always just send Dr. Judd an email and shoot it out to us.
Absolutely.
Okay.
I can do that. Yeah.
Okay.
Absolutely.
Cool.
Carla, are you back? I guess she's not back. Oh, thank you,
Yeah, no problem.
Erica and Sarah. So there's that.
Sarah, you are a beast.
Thank you so much.
Thank you.
That's helpful. You know, there's tons of resources out there. You know, I think I shared with y'all one of my favorite ones is Statistics for people who think they hate statistics. I think he does a really good job. But there's a lot of resources that you can look at and what works best for you. Because what tends to happen is if you don't use it every single day, then when you get ready to use it again, you kind of forget. And you can always pull those manuals out or those examples or whatever and help walk you through those again. You know, it's math. If you don't use math every day, you tend to forget it, or, you know, certain things, if it's just not something you do every day, you just don't remember how to do it all the time. So those manuals, there's a lot of them, and they're fairly inexpensive that you could potentially pick up and have for the future. So we'll do this. I think what Carla was asking was if you're using a scale that has a cutoff in terms of this level is depression, or this level is not depression, or this level is anxiety or not anxiety. I think she was asking if you would ever enter those numbers. And not in multiple regression, you would not, because in multiple regression, you would want to, let's go back to say suicidal ideations for adolescents. You would want to know how much variance in terms of adolescents who have suicidal ideations, how much variance would be explained by anxiety, by depression, by drug use or something like that. So in multiple regression, you wouldn't enter a cutoff score. You would know that in terms of your analysis when you look at it, because you may be looking at differences among the population in terms of their levels of anxiety or that. But multiple regression, you wouldn't consider the cutoff point. It just wouldn't work that way. I think that might be what she was asking, but I hate that we lost her. So she can ask it maybe next time. So let's plan on this. Right now I'm gonna leave homework number 2 due for the 7th because we'll have time. If we need to adjust that date, we can adjust it. So next Monday, I will come prepared to actually use SPSS Live and to run a multiple regression, to run t-test, and to run Anova, and to help y'all see what to pull out of that. And in terms of specifically like what Sarah asked in terms for the model assumptions, and if there's a violation or how you would address those assumptions. Will that work? So we're all good with that. So we'll have a busy class next week, but we'll come prepared for it. How's that?
Sounds good. Thank you.
I'll be ready.
Okay. And I do have the PowerPoint of voiceover for the multiple regression, and I have the PowerPoints and with the examples on there. So that may help you between now and then. Otherwise, we'll do a live running of data and interpreting of data next week. For all 3 of those. And again, t-test and one-way Anova, they're really simple, straightforward. They're fairly easy to do, so they won't take a lot of time. And then we can use the multiple regression, so we can go over all of those.
Thank you.
Will that work?
Yeah, thanks for your help.
Okay, and in the morning I will get your homework number 1 back. All right, and so you'll have that back for that feedback also too before the next one's due. All right. Okay, we're going to have the perfect into the rest of the semester. How's that? The last half of the semester, we're going to make it perfect. Texas weather being all cute today, like it didn't try to kill us last week. So we're going to, you know, I don't want any shootings. I don't want any bad weather. I don't want any illnesses. I don't want pandemics. I don't want any of that. I just want to have a nice normal semester as we move forward. So that's what we're going to hold on to. All right.
Amen.
All right. Y'all hang in there. We'll get through it. Keep giving me feedback so I know what to help you with. Okay. All right. Bye. See y'all next week.
Dr. Judd, can I talk
Yes.
to you for just a quick second before?
You can.
So I am gonna be traveling to Pakistan next week. My grandma's not doing so well.
Oh, I'm sorry.
Yeah, so my